In this lesson, I'd like to show you how to calculate an experimental probability. Let's say I have designed an experiment where I'm going to spin this spinner 20 times, and the spinner will either land on red, blue, or green, and each of the spaces has 120 degrees available to it, so they are all the same area. When I did this 20 times, red came up 7, blue came up 8 times, and green came up only 5 times. How do we find the experimental probability? Well, what's the probability that the spinner landed on red? So we write P of red. And remember, probability is favorable outcomes. In this experiment, it happened 7 times. Out of how many total times? 5, 10, 15, 18, 20. So that's 7/20ths, which is 0.35 or 35%. Any one of these is acceptable. What's the probability that the spinner landed on blue? Well, in this experiment, it happened 8 times out of 20. That can be reduced to 2/5, which is 0.4, or 40% of the time we got blue. What's the probability that it lands on green in this experiment? In this experiment, it only happened 5 times out of the 20 spins, which that can be reduced to 1/4, or 0.25, or 25%. Now, because we had 20 trials, these numbers should add up to make 100%, because 100% of the time we got something, either red, blue, or green, and that is in fact the case. Based on our experiment, blue is the most likely region to show up when you spin the spinner. Now, this might be a little confusing, because if you look at the spaces, you'd say, well, there's one of each, and they're all the same size. It should be equal. They should be 1/3, or 33 1/3%. But you can see in an experiment, we don't always get what we're supposed to. So based on this experiment, we can see these are the percentages. What if I said, what's the probability that it lands on blue or red? Well, a favorable event for blue or red. Well, blue, there were 8. Red, there were 7. That's a total of 15 out of the 20. Which is 3/4, or 0.75, or 75%. You could also say, what's the probability of it not landing on, say, blue? So the probability of not blue, well, not blue would be, anything not blue would be favorable, so there's 7 reds, those are not blue, and there's 5 greens, those are not blue, so that would be 12 out of 20, which can be reduced to 3 out of 5, or 0.6, or 60%. So there's a way that you could find 5 different probabilities from this experiment.